Hello, Assalamualaikum warahmatullahi wabarakatuh. I am Aimar Razid bin Zakaria. Today I want to talk about a case study, which is acetone is being absorbed by water in a packet tower having a cross-sectional area of 0.186 meter cube at 293 Kelvin and 101.32 kPa. The inlet air contains 2.6 mole percent acetone and outlet 0.5%. The gas flow is 13.65 kg mole inert air per hour. The pure water inlet flow is 45.36 kg mole water per hour. Film coefficient for the given flows in the tower are 3.78 times 10 power of negative 2 kg mole SM3 mole fraction, and the single mass transfer coefficient for liquid is 6.16 times 10 power negative 2 kg mole SM3 mole fraction. Gradient for the equilibrium line is 1.186. There is 3 equations given. Calculate the tower height using K prime YA, and B, calculate the tower height using K prime XA, and C, calculate the tower height using K prime YA. Let's go to the solution. Okay. First of all, from the data given, XA is equal to 0.0333 and PA is 30 mmHg. Okay. This is our packet tower. Okay. And the packet tower have gas stream and liquid stream. And V1, L1 is for gas and V2, L2 is for liquid. Okay. This is the information given. Space is 0.186 meter cube. Temperature is 293 Kelvin. Pressure is 101.32 kPa. And the single mass coefficient for gas is 3.78 times 10 power negative 2 kg mole SM3 mole fraction. And single mass coefficient for liquid is 6.16 times 10 power negative 2 kg mole SM3 mole fraction. Okay. The system is operating in the dilute solution, so the liquid in is the same with the liquid out, and also the inlet, which means L1 is equal to L2 equal to L prime. Okay. The question give equilibrium gradient, so that value is used to find equilibrium line, which is this equilibrium line. We need to find this. Okay. Okay, take any value in a graph and substitute in the equation. Okay, I take a value in the graph which is 0.0333, and then I substitute in this equation YA equal to MXN. Okay, YA I got 0.03947. Okay, and the gradient that I have found is 1.186. Okay, the M is 1.186. Okay, the linear relation we can plot xy data to plot the equilibrium line. Okay, this equilibrium line. Plot operating line, and if you want to plot it, we must have two coordinates, which is point 1 and point 2. Coordinate for point 1, which is x1, y1, and point 2, x2, y2. We don't know the value for x1. Okay, we don't know the value for x1. This one. Okay, so to find the x1, we need the material balance. Okay, we need this material balance. Okay, so we substitute all the value that have been given, okay, into this material balance and solve it. And see, we have found the calculation for x1. Okay, the x1 is 0.006479. Next step is finding the operating line. Okay, we have x1, y1, so we can locate point 1, and we have x2, point 2, so we can locate point 2. We have to coordinate to develop the operating line. We have to find the slope, so we have to use the equation for packet absorption column. Okay, so this is the equation for packet absorption column. Okay, which is this one. PM1 equal to K prime SA divided by 1 minus S1 and divided by K prime YA and divided by 1 minus Y1. And from the material balance, so we can find the value PM1, which is we find negative 1.60. Okay, using the linear relation, which is y equal to mx plus c, we can calculate the first y-intercept or first trial slope, and we will get the value for 0.0364. We get the y-intercept is 0.0364. Okay, the value of c. To verify the slope is accurate enough, we have to use the value for yi1 and xi1, which is this. Okay, to be inserted back to original equation for packet absorption column with second trial. Okay, this one. Okay, we must insert it back right here. Okay, we have to solve 1 minus YIM, this one, and 1 minus XIM. And these two equations you can get it from the appendix. Y1 and X1 is already in the question, which is the material balance Y1 and XI1 is from the previous value we get on the graph. Okay, this one and this one. Okay, this is the intercept. Okay, so we can solve both of the equation, which is 1 minus YIM is equal to 0.979 and 1 minus XIM is equal to 0.9901. And then just substitute in the original packet absorption column, then you will get the value for packet absorption column for second trial, which is PM1 is equal to negative 1.61. Okay, and then we can see that the value of slope of first trial, this one, and the second trial, this one, is like close to each other, and then we can say that the slope is, accurate enough. Okay, when I say the slope is accurate enough, meaning that if we still finding the y-intercept for PM1 and second trial, you will get the same value for C, and of course you will get the same value for XI1 and YI1. So you can say the graph is accurate enough, and this is my latest value for XI1 and YI1. This one. Okay, the next step is to find the second slope of the graph, which is PM2. This one. Okay, okay, since we have already have the value of PM1 line, which is negative 1.6, so we can use that gradient to find the coordinate of PM2 line, which is we need to find the coordinate at x-axis using the same gradient. Again, we can use the equation of y equal to mx plus c, where y will be 0 because coordinate of y at x-axis is 0 and m is negative 1.6. Okay, right here. See? 0. And we want to find the value for x and c is y-intercept for second slope, which is 0.005. Then we will get the value for x, which is 0.003. And right now we have find the coordinates for PM2 line, which is 0.003 and 0. Okay? And we just need to plot in the graph and drag from P to this coordinate 0.003, and this will be our second slope. And then after that, we can find the xi2 and yi2, where the intersection of PM2 slope and the equilibrium curve is the value of xi2 and yi2. This one. Okay. After we get the value of xi2 and yi2, we can find that x2 star and y2 star, y1 star and x1 star based on the graph. Okay. This one. Y1 star. And this one. Okay. We must identify this big value because we want to solve for question number C, where we have to use overall mass transfer coefficient on mass and liquid. Okay. Next, we must find xi minus xm, where we have to calculate this equation y minus yim, because we have to use it to find the last equation, which is z, which is question A, right here, z. Okay, we must find it first, but we have to solve this first. Okay, so VAB is from the equation y1 and y2 is from material balance, k prime ya is from the question, and so we want to determine z and y minus yim. So to solve y minus yim, this one, we must look back at the solution we have done before and just substitute it back in the equation. And to make it easier, we can make z as the subject, so it's easier for us to make the unit cancellation. Okay, and VAV is the average, actually the V average, which is V1 plus V2, this one, and divide by 2, and make sure the unit for volumetric flow rates and mass transfer coefficient is standardized. Based from this equation, the unit for mass transfer coefficient is in unit hour and volumetric flow rate for of V1 and V2 is in second. Okay, so we have to standardize. We just divide by 3600, and then we will get the value of VAV is equal to 0.0385. Okay, and then substitute the equation and you will get the value of Z using single mass transfer coefficient in gas phase, which is 1.946. Okay, this one. Okay. Next, to calculate Z for using single phase mass transfer coefficient in liquid, okay, this one, we have to find the value of XISM and the equation for XISM, which XISM equal to this one, which is Si minus Sm is equal to this. Is equal to this. Okay, this is the formula. Okay, and we can get the value of x1 and x2. We can get the value from material balance, and xi and xi2 we can get from the graph. Okay, material balance right here. Okay, and the graph. And the graph. Okay. SI1 we get from the slope number 1. Okay. SI1 we get from the slope number 1 right here, slope number 1. Okay. SI1 which intercept to the equilibrium curve. Okay. Intercept to the equilibrium curve. Okay. And it will be xi1. Okay. si2 from the slope number 2. Okay. Which intercept with equilibrium curve, and then substitute back into the equation, which is L average is actually the same value as it dilute. L1 equal to L prime equal to L average. So just substitute it into the equation. Substitute it into the equation, and we will get the value just a bit the same with a single mass transfer coefficient in liquid. Okay, both looks very close, which is almost 2 meter. Okay. Okay, next we are going to continue to calculate the tower height using K prime YA. Okay. The question doesn't give us the clue of K prime YA to calculate Z. So we need to calculate the K prime YA using the equation. So we must make sure that we pick the correct equation to calculate the packed absorption column. This is the equation calculate K prime YA for packed absorption column. Okay, this one. Where you need to calculate for Y minus Y star M, M1 minus YIM. Okay. This one. And okay. And this one. Okay. Okay. 1 minus YIM and 1 minus SIM is actually we have calculated before. So before we solve our question A and B, so we just use the last trial to calculate 1 minus YIM and 1 minus XIM, where M where M where M prime, okay, where M prime value is actually the value of the gradient of equilibrium slope, which is in the question is 1.186, and K prime SA and K prime YA we can get from the question, and then after that we can solve by k prime ya by rearranging the equation, and after we get k prime ya, we substitute back into the equation. But before that, we must complete to solve y minus y star m and find the appendix the equation to calculate y minus y star m by using equation. Okay, this one. Okay, where we must use the value of y1 and y1, y1, y2 and y1 star, y2 star, and again y1 and y2 we can get from the material balance y1 star, y2 star. Okay, y1 star you can get from the graph from is from P1, and the line to the equilibrium line without going through the slope. Okay, don't let it go through the slope, and go to the left, and then we will get the value for y1 star. See here, right here, and for y2 star is from point 2 where we go to equilibrium line, and this is the value for y2 star, which is 0. Okay, then after you solve the equation, we will substitute all the value into the last equation, which to calculate z, and again what we need to do is rearrange the equation and make z as the subject for easier to do the unit cancellation. Okay, VAV we have calculated it before, and we will find z, which will again is almost 2 meter. It's just the same like question number 1 and 2. Okay, that's all from me. Okay, thank you. I hope my mistake will be forgiven, because I think I made a bit mistake from my talking. I hope my mistake will be forgiven. Okay, thank you.